Let's push the button and get this thing started. I do believe it's time to start our first AMA. So, welcome everyone. Thank you. Thank you for being here as we begin to discuss our vision for Fluent with the community. Today's discussion is on the history of WebAssembly or WASM in blockchains. Today, I'm joined by a really special guest, Dino, the co-founder of Fluent, and he's here to dive into the article that we published way back in September. The article is called "The History of Wasm in Blockchain," and we're here to tackle questions from the community regarding this subject. Now, without further ado, let's hand it over to Dino. Dino, can you share your insights on the article before I take us through the community questions?
Yeah, absolutely. Thanks for the intro, Aaron, and thanks everybody for joining. Definitely excited to get into some of the questions. But I guess just to set the stage, I can kind of give a walkthrough of that article and like more broadly, I guess how we look at so obviously the history of WASM and how we look at that relative to the future of how it's used in blockchain. Um, so I guess where we started off the piece, and I think is a good initial thing to understand is kind of the inception of WASM and where it actually came from. Because this is something that has history in Web 2 and some like pretty meaningful history in Web 2. So um, first off, WASM, what is WASM? Stands for WebAssembly. It is a low-level portable binary format and compilation target for high-level programming languages. So, what does that actually mean? So let's get into it. Um, the web obviously has the web more broadly obviously has a very long history at this point, and it began with like very kind of simple static pages, right? And then it kind of evolved into these full-blown applications, like very dynamic, and people just started putting kind of like more and more stuff on on the web until you really did have these kind of full-blown apps. And so it started to get more and more dynamic over time, and that's when kind of JavaScript was introduced. So it became more programmable. And that obviously blew up, and it became this like very, very popular thing. And everybody kind of learned, to use JavaScript. And at least to a certain degree, that was good for many applications, but it did kind of constrain the design space in like a pretty meaningful way. And like anything else, like as a system gets more and more popular, you have developers who are just trying to push the boundaries. What new experiences can they build? How much better can they make those experiences? And generally speaking, what we found is developers want to pick the best tool for the particular task. And so people, as much as JavaScript was great for many of these web applications, and obviously the internet and the web got very, very popular over a number of years, clearly, it was still limiting factor. And so then what you start to see is people use um, WebAssembly as this primitive to unlock a broader design space. And an easy way to think of that is by enabling these different languages to actually run in the web browser. So you got languages that are, and so it's like, okay, why would you want these new languages to run in the web browser? Because they unlock different functionality, each one of them. I mean, there's a reason that there isn't just one programming language that's used universally for all use cases today. You have like Rust, you have Go, you have C, C++. I mean, these are all like different things. Sometimes people just have their preferences on how whether the syntax goes. Like some people just like different programming languages, but there's also like kind of more concrete reasons you might use one thing or another. Like C++ is like way more performant than like Rust. Like you get like lower level control with a lot of these languages, and it can enable better experiences, functionality that wasn't previously possible on the web, and in the context of where kind of WebAssembly began, and also kind of new experiences for your end users. So people get that, and there was obviously demand. So this WASM thing unlocked that full design space, and so it grew and grew and grew, and now I mean it actually got popular enough to where Wasm kind of broke free of even its intended purpose on in the web browser, and now it's actually used for backend applications and kind of in server environments to solve the similar problem, to like add kind of this new level of programmability, flexibility, and efficiency. Some of the companies that use Wasm today are like Shopify, Figma, Netflix. We go through some of them in the article and kind of touch on the specific ways in which they are used. I'll kind of zoom into one of them that I like to talk about, which is Figma. And Figma, if anybody doesn't know, an interactive design tool that completely disrupted the design industry over the past, 5, 10 years. And I mean, they just sold. I mean, I actually think the deal ended up falling through with Adobe, but I mean that doesn't have to do with the fact that like they, they grew to a $20 billion valued like company, completely disrupt the design industry. And the way that they did that was really centered around this new type of experience they were able to offer, honestly, with Wasm at the core. Like the whole Figma transformed the industry by being interactive in the browser in a way that that type of application was not able to be interactive in the browser before. And that's completely to do with the fact that they were able to use C++, they were able to use Rust and kind of blend that into some of the more kind of like browser native um, programming languages to create this like 10x better experience, which clearly the market valued. And you can actually look, they have a lot of content on this, some videos, some blogs themselves. I'm sure we can kind of plug those in some kind of show notes. But basically, like they'll talk about it exactly this way too. It'd be like, hey, we were like an early adopter of Wasm, and it totally unlocked this new thing. And where does that get them? $20 billion exit. Like pretty incredible. So I think that's a pretty cool um, example. And they actually, in one of the videos, they kind of stepped through the specific reasons why they wanted C++ for a certain component, why they wanted Rust for a certain component, why they wanted TypeScript for a certain component. And so um, basically, and so you get the idea there. I'm sure there's a lot of other use cases that I'm sure we can probably have completely of full conversations on. But just to segment this into Web3 a little bit, it's also been very Wasm has also been very popular in the blockchain space, and for these same types of reasons. And whether it's Cosmos, Near, Polkadot, we list some of these in the article as well, but there's been a ton of different blockchain ecosystems that over time like recognize this advantage that kind of Wasm execution has, and they've incorporated it into the blockchain space. And so the reason is the same. It provides this like efficient, very flexible environment. Um, and so you say, okay, well, hold on. There's a question. A natural question is if there's this toolkit that unlocks all of these use cases and makes it way easier for kind of like Web 2 native people to adopt because it is coming from kind of like a Web 2 native environment. What happened? Why aren't some of these chains that adopted Wasm execution like proliferated? Why haven't they beat Ethereum, these maybe Ethereum killers at the time? And why haven't millions of developers been like on board on chain? And I think a key thing to hone in on is the fact that previously in like kind of the monolithic era of blockchains, where kind of like the consensus and execution and all the functions of a blockchain were like packaged together in one big fat piece of code, you kind of had to like reach escape velocity on like the ecosystem, like the L1 ecosystem, um, before you got your execution environment to be widely adopted because they're like attached at the hip. And as a lot of people probably know, like that's an incredibly hard thing to do, actually make like your L1 consensus layer and like social layer around it truly decentralized to a point where that reaches escape velocity. And only then can the execution environment really proliferate. So there's almost been like a prereq like it almost didn't matter like how good Wasm was as an execution environment. There was kind of like this prerequisite that like most of the L1s in the space had a really hard time overcoming. But what's really cool about that is modularity solves this. So rollups, the advent of like rollups and modular blockchains If anyone's not familiar, kind of separate the execution environment from the consensus environment, right? So it's like a separation of concerns, specialization. So what that unlocks is these new novel VMs and now L2s and execution environments, they don't have to like they almost get to bootstrap on top of the network effects of a consensus only layer, and they get to jump right past that big problem that actually um, was really challenging for a lot of like the previous monolithic blockchains. So basically, modularity and rollups solve this problem, and now we are at a point where we can build these novel execution layers on top of Ethereum using things like Wasm, and that's kind of um, where our value add is. We're taking and saying like, hey, this has always been like a good execution environment. There are these other hurdles that were in the way, but now Wasm based chains or Wasm based other types of like scaling solutions can just proliferate on top of, in our case, Ethereum. And so in a sense, we're taking like the most popular like execute, the favorite execution environment from Web 2 and the kind of favorite consensus environment from Web 3 and kind of blending them together. And we think that this is like a pretty interesting point on the trade-off space. Um, so I'll stop there for a second. I mean, I kind of breezed over a number of things in the article, but hopefully that at least kind of sets the stage for how we're thinking about it. And I don't want to, take up the full half hour. So I'll pass it back to Aaron.
No, that's really great stuff and amazing for the community to hear, where some of our early thinking's coming from. For me, it's really awesome to see how builders are applying lessons learned in Web 2 when designing Web 3 architecture and how Fluent's playing into that. So I'm sure the community found it helpful. Um, Next, I think it's time to answer some community questions if you're ready, Dino. Are you ready?
Let's do it.
Awesome. First up is a question from Khalid, who may have had this answered in your recap, but if you can briefly go back over it and talk about Watson's impact on general purpose languages. Specifically, their question is around Python, for example, which they say is very popular. How does this open up blockchain development to different types of developers like Python?
Yeah, it's a good question. So, for those not familiar, I mean, Wasm is a compilation target for a bunch of different languages, and more of those languages are being kind of supported as like, the years progress. Um, and there, so I'll answer that kind of like through a broader context. I mean, you can work with Python using WebAssembly. It's not as like well supported, I'll say, as some of the other languages like Rust on the other side of that spectrum, which is like very well supported. But the cool thing is like as Wasm gets more and more popular and becomes kind of more of a standard across the board, Web 2, Web 3, all of it, more and more better and better support for all these languages kind of builds over time. So like but more broadly, like how does it open up development to different types of developers? It's kind of like there's two ways to look at that. So number one, putting myself in kind of like the Web3 native shoes, um, it opens up, frankly, Ethereum to new types of developers who might, who might have spent time building in Rust smart contracts in one of these other ecosystems, or just has like a preference for Rust. Um, maybe it's because they are first, maybe it's because they already built things on like a near or on another one of these chains, and they've wanted to tap into the benefits of Ethereum, such as like the liquidity and kind of like the network effects in general, but have not previously been able to. So it opens up more developers specifically to build on Ethereum, which is a pretty cool thing. And we're seeing a lot of excitement around just, TypeScript, Rust, smart contracts. Um, so that's one thing. But there's also kind of like, but even to get to that point, the reason I framed it around being like for Web3 natives is because there's the learning curve of even just being able to program in like the smart contract paradigm and kind of start from scratch with like tooling and libraries. What WASM unlocks is the ability to actually not even have to program in the smart contract paradigm for certain application specific use cases. And because it offers support for kind of just general purpose programming, you can actually go ahead and take a lot of like the libraries and packages from Web 2 and actually kind of make them verifiable and effectively deploy them on Ethereum, which starts to become really, really cool. And that I think is a much bigger unlock, which ends up opening opening up possibilities for millions and millions of Web 2 native developers to actually build on chain in various capacities. And of course, it's not black and white, right? I mean, these lines blur together. Like, somebody might 70% of their application might be in just pure kind of like Web 2 code, and like they're not even dealing with it's more app specific. They're not really even dealing with like financial things in nature. They just want it to be kind of like provable on chain. And they might use all the existing libraries that exist today in Rust, for example. And then yeah, they might, since they have that base of Rust knowledge, they might learn a little bit of smart contract programming and kind of like include some financial mechanics for the other 30% of that experience, but it's still going to be easier and way better than if they had to do everything in Solidity in just smart contracts. So that's kind of how we think about it.
That makes a lot of sense. Thank you, Khalid, for that great question. I hope that gets it answered for you. Gonna move on to another one. We've talked about ZK Wasm's increased popularity in Web3. So we have a question from Mob and Ghoul, and if I mispronounce your name, please feel free to yell at me in Discord. They want to know, what does Fluent do differently from other zero knowledge layer 2 solutions? Essentially, they feel that the market is becoming increasingly saturated, and they really want to know, how does Fluent differentiate itself?
Yeah, so I think some of this probably has to do with the languages that I mentioned before, but I'll try to add some like new elements. Um, first I'll step back and kind of like paint kind of the landscape a little bit. So the vast majority of layer twos, while there are a lot, the vast majority are EVM. So just to start there, if they are EVM rollups or L2s, and they just support Solidity. Um, so far, we haven't, even if you could look at it and say we're like competing in terms of just like block space on L2 that people could use. But in reality, when you put yourself in a developer's shoes, we're finding it's not that competitive. Like typically developers, at least that we speak to, understand like pretty deeply that like different tools are better for different tasks. And so it's usually not the case that a developer will say, "Oh, you know what? I have this certain game I want to build, and maybe I'll build it in Solidity on an EVM L2, or maybe I'll build it in Rust on a ZK Wasm L2." Like they're usually already at a point where they're saying, okay, Solidity is not the right thing for this game that I want to build. What are the alternatives in order to build? And like Rust is the best possible language for me to build this application. So what are my options there? And I think the cool thing is we are actually one of the only like solutions on Ethereum that enable you to do this. And I think that people have been very attracted to that. And so as much as there are a lot of L2s technically, I don't really look at a lot of them as competitive. So I think that we're actually just starting to explore the design space of what's possible with these like non-EVM L2s. And I think that it's like we're just scratching the surface on that.
That's amazing. Yeah, I agree. I feel like it's more about having the power to pick the right tool for the job. Um, let's move on. And to move on, I think I want to back up just a little bit and talk about the news we recently announced last month about our private testnet and our initial launch partners with a wide array of integration potential on Fluent. So next up, we have a question from 0x Morgian, who wants to know, as Fluent has envisioned a more permissionless and an innovative future, they're curious about the potential synergies with other emerging technologies. Are there any specific emerging tech trends or developments that Fluent's keeping a close eye on? And how might they complement or enhance the impact of Wasm execution on Ethereum in the coming years?
Yeah, good question. So synergies with other emerging technologies. We definitely see that a lot of I think there are a lot of problems that can be, I mean, this can go a lot of different directions, honestly, but I think one area that is just like very prescient right now is like the AI space. I think that people are starting to see like how urgent solving some of those problems are, and I think blockchains are at a point where like they can really help with that. Um, and this can be done in a lot of different ways. Like I actually think and by the way, this is cutting through the hype because because there's obviously a lot of hype around like AI meets crypto. But if you really dig into it, there are a lot of things there. You just have to be like very precise with like what problems you are actually trying to solve. I mean, I think that there are some problems around excuse me, actually just to paint the broad stroke, you're seeing this like very intense bifurcation in like the AI space. There's like the cohort that thinks, that's more like closed AI, and then there's the cohort that's more like open source AI. And you're seeing these conversations and tension at this point in time where, some people are very worried about AI being like built, controlled, managed, monetized in like a closed way. And especially because of how clear it is that this technology is going to be like extraordinarily impactful, and power like our society basically in so many different ways going forward. And so I think that it's like a very unique period of time where we as an industry, frankly, have the opportunity that we can show like that blockchain can solve a real pressing problem that's on everybody's minds. Like the same way everybody's mind, like the fact that like ChatGPT, for example, has permeated the minds of just like the everyday person at this point actually creates yet there's also that carried worry in their heads. I think it presents like a really amazing opportunity for us as an industry to just show to the average person, those same people, that like, hey, we can really solve problems here. And so that can come in many forms, right? That can be mechanisms to help bootstrap open source models. That can be kind of like attestations, like attestation primitives, like Ethereum attestation service that like helps distinguish what was made by a person versus a generative AI model. There's all different flavors of that even. So I mean, the rabbit hole goes pretty deep. Like you can, it could just be like a known ENS name, and like you pin that as the source of truth, because just socially, like everybody knows that Aaron is associated with a certain ENS name. Or you get into the proof of personhood stuff, and there's kind of a whole design space there that we're really excited about. We're also working with a couple of partners who are doing verifiable machine learning. So one is Giza, who are focusing on kind of like smaller models, making sure that they're computationally like verifiable, making sure that like the inference of these models are actually being computed correctly. And why is that important? Because these models are being incorporated into DeFi. So it's like you have this fully decentralized system. I mean, and yet yet one of those inputs is centralized as a model. Like it doesn't really make sense. So you want the kind of full experience to be decentralized, and so they're seeing a lot of traction there. And we're also working with another partner called Hyper Oracle, which is actually starting to focus on larger models. So some of like LLMs and doing the same types of things. And so anyway, I guess I'm going kind of too deep into like the AI route specifically, but that's certainly one area of emerging technologies that we're like very, very excited for. Um, so I'll stop there.
Great stuff. Now that's very interesting to hear how Fluent is really being value additive to some of the emerging technologies like AI and creating more secure environments. So great. Good. I'd move on and go to a question from Y5. Now this one might be a little bit more technical, but I think it really speaks to like the evolution of our project over the last few months. Um, what they want to know, they've been following the project for a while and they're big fans of folding base ZK Wasm. They're curious about the evolution of our docs and code base, where we've mentioned Nova folding in the past, but in our GitHub, they noticed there's some libraries about Halo 2. Can you kind of go through at a high level some of the technical things that would explain the ZKP schemes in the Fluent ZK Wasm?
Yeah, absolutely. So good question, because we do mention like a few different types of kind of proving systems and different types of schemes in a number of different places. So the TLDR there is we have done a lot of research into a many of these different proving schemes. So where Nova comes in, and Nova we find like really, really promising, that is because we have done a meaningful amount of research, and we've published that research just in case it'd be helpful to anybody else. Currently, in the implementation of the product today, we do use Halo 2 as our proving system. And the reason, there's pros and cons to Halo 2, of course, like anything else. And we're using it because it is just like a tried and true thing. Like it is very tested. There's a lot of kind of, tooling built around it. And just with our kind of like lean kind of startup hats on, we thought that was like a really good place to get started. That said, there are amazing innovations happening in kind of like the ZK space, and we're paying close attention to a bunch of other ones. Like there's no reason we have to like stay using Halo 2. We've actually done a decent amount of um, exploration into like Plonky 3, and we're really, really excited about Plonky 3. And I do think that could be where we head in the longer term. And but right now, I think it's really important that we ship, we get the network up. I mean, there's certainly way more to to building like a general purpose L2 system than just the proof part. So we definitely think it's important that we like, we get the thing off the ground, we get as much developer feedback as we possibly can, and then we kind of iterate from there. Um, so yeah, I think that just about covers it. Maybe there are other specific like proof systems that we've mentioned in previous times, or maybe like in our research docs or something like that. But I don't remember exactly what those are. So feel free to ping me.
Awesome. I'm sure that's really helpful. Since that one was a pretty technical question, let's move to something a little easier to follow. And probably the most common question that we get, or at least the thematic of a common question here. Dino, can you tell us anything about the future roadmap and what to expect in the near term?
Yeah, absolutely. So we are right now we released our private testnet. So we do have a group that we published in one of our blog posts recently of projects working closely with us. We are trying to move quickly towards a kind of second release of that private testnet, which comes soon. And this is just kind of sprucing up the SDKs for kind of like Rust and enabling Solidity support. And then hopefully within, the next like couple of months, we're really trying to move quickly towards a public testnet so we can kind of open the doors for anybody to kind of permissionlessly come in and experience the network. Um, and then, yeah, I mean, that's probably all I can say right now with confidence. But hopefully within the next like week or two, we're going to try to publish like a public roadmap. So there should be more information soon.
Awesome. I'm sure the alpha hunters out there are excited to hear it. Um, this looks like a really good place to stop until our next AMA. We're almost at time, but this was a really great first AMA, and I think the community has a lot to think about. So thank you for really jumping deep into some of these topics. Before we go, is there anything else you want to say?
Um, no, I mean, well, th yeah, thank you for hosting it. Thank you everybody for joining. I mean, we're really accessible. Like if you're a developer specifically, or if you have, for if you have questions more broadly, of course, like reach out to any of us. We are looking for kind of our next cohort of developers to try out the testnet. I think that's kind of like the highest like urgency thing for us right now. So, if you're excited about kind of what's possible to build in Rust, in TypeScript, in Solidity as well, or maybe blending these languages together, if you're excited by some of the stuff that we're enabling on Ethereum, please do reach out. Like we will take the time and talk through like using the system with you, and we want to make sure that we empower even indie devs to get off the ground with their ideas. So yeah, I mean, feel free to reach out. We're here. We're in the Discord, and yeah, definitely excited to do more of these.
Well said, and thank you. Let's thank Dino, everybody, on behalf of the entire community for coming out and answering this question. And on behalf of the entire team, we want to thank everybody for being here today. If you didn't get your questions answered, there were a lot of great ones in the channel that I didn't get time to review. We'll have plenty of opportunities in the future. Look out for a blog in the very near future. We'll answer some of the better questions that have come across in the last 24 hours. We'll also be publishing this to YouTube to give everybody a chance in an archive to review the AMA. In the meantime, like and follow us on Twitter at FluentXYZ, and stay active in Discord. Thanks, everybody.
Thank you all.